All right, hey, Kellen. We still have one section left to do in chapter 5. It is like this section, 5.3. 5.3. But before we do that, we have lots of formulas going on. And so we're going to start to fill out this formula sheet, which is at the back. It is a yellow sheet. Everybody should have one. And we're going to fill out these 4 rows that have to do with 5.1, 5.2. Okay, this sheet is the formula sheet that you get to use on your test. Okay, so make sure you have this filled out. Make sure you know how to use this formula sheet. We're going to do that before we do 5.3, and I add more things to you just to kind of like summarize everything that we've learned so far, so I'm not adding things to you and you get even more so overwhelmed. Okay, so we're going to kind of close the book on these 2 sections before we open up section 5.3. Okay, good. All right, here we go. Probability distribution, we're doing mean, variance, standard deviation. I'm going to start with my example up top here, and we're going to actually make a table up here, okay? But I got to figure out, do we want to do the coins table? Sure. Actually, let's do the kids, the 3 kids table. Let's do that one, because we've already done the coins table. Okay, here's your table. X and P of X. Okay, over here in my formula, I'm going to do it right here. I'm going to say when 3 babies born. X equals the number of boys. P of X is the probability of that happening. Okay? We'll talk formula here in a second and important info here in a second. But I'm going to fill this table in. Okay? X is the number of boys. Okay, so you don't have to write this list down, but when we have 3 babies born, right, we could have a boy, 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 a boy, boy, girl. Don't write this list down. I will write it for you. Boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. How many in that list? 8, because 3 babies, 2 times 2 times 2 is 8. So there's 8 in this list. All right. Now, X is the number of boys that we have, right? So if I have 3 babies, I can have 3 boys, which means 0 girls, right? I gotta have 2 boys and 1 girl. I gotta have 1 boy and 2 girls, or I gotta have 0 boys. Does that make sense? So I really like, if it helps you to do the other column that talks about the girl column, that's fine, right? But this is specifically talking about boys, the number of boys that I have, right? Okay, so assuming that boys and girls are 50-50, what's the chances of me having 3 babies be born boys? 1 out of 8. There's only one combination that will give me 3 boys. 1 out of 8 is 0.125. Okay, how many will give me 2 boys and 1 girl? 3 out of 8 also. That's 0.375. Okay. One boy would be this one, this one, this one. So another 3 out of 8, 0.375. And girl, girl, girl would be the only last combination that I have, which is 1/8, which is 0.125. That's my probability table for boys when I have 3 babies born. Yeah? Okay, so that's my probability table. Now we have to find the average. Okay, so we're doing just the mean of a probability distribution. That's my probability distribution. I need to find the mean. The mean equals mu. Sometimes they'll ask for the symbol. The mean is mu. Okay, the formula for finding the mu is, do you remember how to find the average number of this happening? How do I find the average giving the table? Yeah, multiply the columns and add. So if I add them together, that's saying find the sum. And if I multiply the columns, I am multiplying the x's times your p of x's. Okay, so if I write this down as a formula, does that mean, like, can you understand that? Yeah. Okay, I take all the x's times the p of x's, and then I take the sum of those, right? Yeah? Okay, so in my solution, I'm going to like zoom out here a little bit, okay? I'm taking 3 times 0.125. I am taking 2 times 0.375. I am taking 1 times 0.375. I am taking 0 times 0.125. Do you see where I'm getting this information from? If you don't need to write this down, like, don't write it down. if you already know how to do this. Okay, I know that 0, I know the bottom one is this. I know this one is 0.375. I even know the third one. The third one is 0.375. This one is that one. 2 times 0.375 is, I gotta think, 0.75. Yeah. If I add those all together, that comes out to be 1.5. Yeah? Okay, here's what this means. This is my average. This means if 3 babies, the average number of boys equals...
One of them's a half-breed.
Sure. Okay, does that make sense? The average of 3 would be 1.5 if you're splitting it in half, right? Okay. Now, I understand, yes, you can't have 1.5 boys, whatever, but like that would be the average, right? Okay. So that's how you interpret that. That is the mean. That is the average. Yeah? Okay, now I put variance and standard deviation on. Are we done with the average? Can we move on to variance standard deviation? Do you remember doing this process? Yeah? Okay, variance. Let's go down here. What symbol do you use for variance? The circle with a hat, and he is squared for variance. Standard deviation, he is just the circle with a hat. Do you remember what he's called? What is this symbol right here? That's sigma. Okay?
That's a sigma?
That's a sigma. Yeah. There's also like an uppercase Greek letter that's also called sigma, I think. Yeah. Okay, so variance, standard deviation. All right, so variance. He has kind of a long formula. Sigma squared is equal to the sum of all, and I'm going to look before I erase and lead you astray.
I'm pretty sure the sum symbol is a uppercase sigma.
What?
Yeah.
The sum symbol.
I thought that was, that's sigma.
That is sigma.
Yeah, maybe. Yeah, mine doesn't have like these little guys on him, but yeah. All right. Boop. Like this. What's that?
Can you open Mr. Henderson's door?
Yeah, grab my key right here.
Okay, thank you.
Okay. Formula, here we go. X minus mu squared times P of X. Okay, make sure this is a minus and this is a times. And not a multiply, because a couple of Chloe was doing that. Megan was doing that, right? Make sure this is a minus and that's a times. Okay? Now, this guy, how do I find that guy?
Square root.
The square root of that junk. So there's your formula. Okay, because this is so long, I mean, like we're using that same table from up above, right? So I'm going to use like these two for the solution. Okay? All right? So we're doing that stuff. Okay. So first line, I've got 4 lines. 1, 2, 3, 4. Okay, first line, I'm taking x minus mu squared times p of x. X minus mu squared times p of x. X minus mu squared times p of x, and x minus mu squared times p of x. Okay? All right, what's my first x? 3. Minus, what's mu?
1.5.
Mu is 1.5. Okay, times p of x for the first one is 0.125. Okay, I'm going to do that, and I'm going to get a number.
Hey, is this the other turkey?
Yes.
Where's the other turkey?
I don't have another transfer. I accidentally only ordered one. So I have to place an order for transfers today so that it comes in before Thanksgiving. But I need $29 in order to get free shipping. And we already have 2 screwed up from Dylan's, of course. Like, that would check out, right? So I have 2 that I need to order.
And shirts.
You have transfers and shirts to order? Perfect, okay? So I need to get those today sometime because I have to order that.
The pumpkin pie is cute.
Yeah, he's cute. Okay, all right, 3 minus 1.5 squared times 1.125. Somebody got it? A couple people do it. It wouldn't hurt to actually practice doing this. FYI.
I know how to do it. Why do you
All
always look at me?
right,
when
all
you
right.
do
I'm
that
just
stuff?
saying, some people do minus, some people do multiply.
281.
0.281. Okay. The second one. What's my second x?
2.
2 minus
1.5.
still 1.5 times the second p, 0.375. Do we understand where these numbers are coming from? Yeah?
0.0937
What I got.
Let's go 0.094, whatever, it's fine. Since we did the first one to 3 decimal places.
Same with the next one.
Okay, the next one, the next one, we take 1 minus 1.5 squared times 0.375. So that's the same. Now, it's the same because 2 minus 1.5 is 0.5. This is negative 0.5, but when we square it, it ends up being the same as that one, right? So that one is also 0.094, right? And then the last one is the same as the first one, right? Minus 1.5 squared times 0.125, okay? That is 0.281.
That's something.
How is it
Okay.
the same?
How is it the same?
One
Because
point
our
five
table
squared
is
is
symmetric, right? So like 3 minus 1.5 is a positive 1.5. This is a negative 1.5, but when I square it, it's gonna end up being positive, yeah. What'd you get? It's a normal distribution, yes, so that's how that works, yep. What'd you get for adding them together?
I did.
Anybody? I got 0, carry the 1, I can't,
Why not?
because you're gonna get it faster than me.
0.75.
0.75, hey, perfect. Okay, so that is, 0.75 is the what?
Variance.
The variance, 0.75, 0.75. Okay, standard deviation is this guy, which is the square root of 0.75, which is what?
866.
0.866. That's the standard deviation. 0.866. Beautiful. Okay, good?
That wasn't that bad.
That wasn't that bad. All right, we remember doing that kind of, maybe, ish, hopefully? Yeah? That's if you're given a table, all right? Now, binomial. N, R, P, Q, just so you know, sometimes they will call R X. So I'll put that in there. Sometimes the book refers to the R as an X. Okay, do you know what those things are, or should I write them down?
No, got it.
Total, number choosing. If you don't want to write this down, you don't have to. Choosing. P is the probability that you want. This one's the probability that you don't want. Okay, formula? Do you have it memorized?
NCR
Yep, that's the first chunk.
times
Times P to the
And,
R, that's the
Oh,
first,
R.
second chunk.
and times q to the n minus r.
Q to the N minus R.
That's the probability that you want is like there, and then it's the probability of what you don't want.
Correct.
What you don't.
Yeah. The probability of who you want and how many you want them. The probability of what you don't want and how many you don't want.
It just
Right?
makes sense.
Yeah, it just makes sense, right? Okay? All right, what should we talk about?
Dynamite days. Dynamite days. Must be Italian.
Shut up.
What movie is that?
We've done games, we've done killing trees. What should we do? Something that has a binomial probability. 2 outcomes. What? Killing frogs? We need a binomial, something
I have a
that has 2
video of me
outcomes.
killing a frog.
Good job, Jason.
I shoved firecrackers down its throat. And I
Ugh,
went-
let's not do that.
Pass fail.
Pass fail, I like it. Jace
What?
has, what's the probability of him passing?
0.1.
Let's give him a little bit.
0.11.
40% chance
Oh, I
Of
was.
failing.
of passing
They don't think you'll pass.
an assignment. Let's say a test. Passing a test.
I haven't failed a test yet.
If, I'm just joke, like, we just need an example. If 10 tests,
Just run.
find the probability that he passes. I'm gonna put this down a row. Find the probability that he passes how many?
3,
5.
8.
We'll go, I like 8. Probability that he passes 8. Okay, I like it. Now, if he has a 40% pass rate, and I'm filling this table out, right? Okay, I'm not gonna actually write this table down, so don't write this down, right? I have X and I have P of X. This is him passing all 10. This is passing 9, passing 8, passing 7, passing 6. Don't write this down. 5, 4, 3, 2, 1, right? And the probability of, and 0. That's the probabilities of him passing that many tests, right? Which one of these probabilities will have the highest chance of happening?
Right? Yeah.
4. Because his pass rate is 40%. So this should be the highest. Does that make sense? Okay. And then which one should probably be the lowest? 10, right? Because it will be skewed like this way, right? So like 0 might be similar to like what 8 would be, right? But 10 would be the lowest. Does that make sense? Because he skewed that direction. Okay. We see how this table like fills out. Okay. So that is that. All right. I'm going to erase this table. Let's go ahead and actually do this problem. Blah, 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 blah. Here we go. All right. Let's fill out NRPQ. NRPQ. What is N?
10.
10. What is R?
8.
What is P?
40.
0.4. Q? 0.6. Okay, let's fill it in. 10. C, 8 times P is 0.4 to the how much? 8. 0.6 to the 2. Okay. All right.
This is very nice, guys. More faith in me.
Yeah.
0,
I had faith in
1,
you,
0,
Jace.
6.
0.0106. So that is a 1.06% chance that he gets, if his pass rate has been a 40% chance of passing a test, the chances of him passing 8 out of 10, not looking good. Okay? Is it significant?
It's it.
Is it?
That's not
Is
what I
it?
got.
Is it? That's not what you got?
You did it wrong.
I put
Is it significant to pass 8?
Yes. Oh, wait. I guess we have.
And whenever I think of significant, I think of rare. I kind of insert that word in there. Like significant confuses me. Is it rare for him to pass 8 tests?
Yes. No.
Yes.
Insanely.
1.06% is less than 5%. So it would be a rare occasion for him to pass 8 tests. Yeah? Does that make sense? Beautiful, beautiful.
We have
Love
like
it.
no time.
Oh, we got one more thing. What time do we get out of here?
Oh, 2.
I know, I'm on 02.
Like 3 minutes.
We don't have.
We don't have.
We'll write the formulas down. We'll write the formulas down.
Oh my God.
Brother. This information is the same for down here.
It's empty. Yeah. No.
Mean
No. Die if I do.
is mu, and there's a formula for mean. Variance is sigma squared. There's a formula for that. Standard deviation is still sigma, and there's a formula for that.
You're a thing.
Okay?
Shut up.
Make me.
Dude, I will.
Okay, now, keeping in mind mean, variance, standard deviation, it's the same mean, variance, standard deviation that you were finding up here. It's just you are given different information to begin with. So for up here, you were given a table, and the only way of finding that is the ugly way. Here, we're given NPQR, and the only way to find it is a nice, easy way, okay? So if Jace has a 40% chance of passing, and we give him 10 tests, how many tests will he pass?
4.
4, because you took N times P, right? Which was 10 times 0.4, which is an average of 4 tests that you should pass. Yes, yes?
Nope.
Make sense? Okay. Variance is N times P times Q. N, P, Q. Which is 10 times 0.4 times 0.6. That is, you can do that in your head. What?
10.
No.
I lied.
10 times 0.4 is 4. What's 4 times 0.6? 2.4. Right? 4 times 6 is 24. 2.4. Yeah. All right, standard deviation is the square root of NPQ, which is the square root of the variance. And this, so that's the square root of 10 times 0.4 times 0.6, or the square root of 2.4. And that is like, I don't know, 1.1 something.
I got it there.
I don't know. Somebody have a square root or a calculator. Take the square root of 2.4.
Actually.
I don't know.
Square root of 2.4. And we'll be done.
1.55.
1.55. Okay. 1.55 is the standard deviation. All right, I have one more thing that I want to add to that not today, because we don't have time. One more thing I want to add to that, so help me remember before we start 5.3 tomorrow. I want to add one more thing on the bottom here. Okay? All right, there you go. Beautiful. Goodbye.